Okay, okay. I think in last session I am discussing about your Underwood's exponential method, which is used for your calculation of your traffic parameter. So basically, I discuss all the things. So just wait. So I think we cover. So basically, in last session, I discussing about your pipe generalized model. So next model under microscopic model is your, just wait, is your pipe generalized model. So next model is, I think this is your model number 4. So model number 4 is your pipe pipes pipes generalized pipes generalized model. Pipes generalized model. This is also your microscopic model, because in microscopic model we discuss about your three model. One is your Greensill model, next one is your Greenberg model, next one is your Underwood's exponential method. So basically these all models are related with your traffic parameter. With the help of these all models, we just calculate the relationship between K, Q and V. So in order to generalize the modeling approach, pipe introduce a parameter n. So basically in this method we take a help of parameters which is n. So basically the researchers who suggest this model will propose a model represented by this equation. So basically this is the equation by which pipe generalized model will be represented. So basically V is equal to Vf, V is equal to Vf 1 minus K by Kj, 1 minus K by Kj, 1 minus K by Kj to the power n. This is the pipe generalized model. So basically when n barabar 1, pipe model resembles Greensill model. So basically when n barabar 1, when n barabar 1, then this model, pipe generalized model, will be your Greensill model. Greensill model. SHIELD, Greensill model. So basically, Greensill model also gives a relationship between V, Vf, K and Kj as V is equal to Vf 1 minus K by Kj. So if you put here n is equal to 1, then this is your Greensill model. So this is your Greensill model. So thus by varying the value of n, families of model can be developed. So basically when we vary here the value of n, then we get another model. Just here we take n equal to 1, we get Greensill model. If n barabar 2, then we get another model. So in same manner different models can be developed. So basically in pipe generalized model, the modeling approach is introduced in this method by introducing a new parameter which is n. So basically this is our new parameter which is introduced here n. Now we know the basic relationship between V, Vf, K and Kj. So pipe generalized model, we represent the equation which is V is equal to Vf 1 minus K by Kj to the power n. When we take n value as 1, here you all see, when we take n value as 1, here when we take n value as 1, then green shield model will be obtained. So thus by varying the value of n, families of model can be developed. So basically different families of model be developed. So I think I cover 4 models which is under your microscopic model. Next model is your multi-regime model. So move toward next model. So just wait. Next model. Next model is your Next one is your multi-regime model. So I think this is your model number 5. Model number 5. Model number 5 is your multi LTI multi regime models. Multi regimes GIMES multi regimes model. This is the next model under microscopic model. So basically all the above models are based on the assumption that the say speed and density relationship is I think linear, but this method is valid for the entire range of density in traffic study. Hence this model are also termed as single regime model. So basically another name is given to this model, that is basically multi-regime model is also known as single regime model. So this is another model. So however, human behavior will be different at different density, hence density speed relationship will also be different in different zones of density. So based on this concept, many models were proposed termed as multi-regime model. Example, two regime model. So basically if you see the representation of velocity and density, here your v is given, here your v is given, here your density is given. So this is your I think this is a section which is under consideration. So basically this is our section which is under consideration. From here to here, a constant or a straight line will come. Now here our curves will or a straight line will go down. So this is zone 1, this is zone 1, this is zone 1, this is zone 2, this is zone 2. This is zone 1, this is zone 2. So basically all the above models, that means all the green seal model, green bulb model, uh, under Wood's exponential model, and last one is your I think pipe generalized model. all the models are based on the assumption that the same speed density relation is valid for the entire range of density in traffic study. Hence, these models, that means multi-regime models, are also known as single regime model. We know that human behavior will be different at different density. Hence, density speed relationship will also be different in different zones of density, which I also plot in your diagram. So based on this concept, many models were proposed. So this is your multi-regime model. Example is your two-regime model. So I plot, this is your two-regime model. So basically this is zone 1 and this is zone 2. So if only one zone is present, it is your single regime model. That means this is if only zone 1 is present, this is your single regime model. But here two zones is present. So basically this is known as your double, this is known as your two regime model. So I think I covered 5 model. Next model is your Shockwave model. So what is Shockwave model? Just observe. So this is your Shockwave model. So just wait. Just wait. Next one is your Shockwave model. So here next model is your Shockwave model. Sixth one is your Shockwave model. Shockwave Shockwave model. Shockwave model. So just observe the diagram. So basically here this is your pipe configuration. This part is your expanded part and this part is your contracted part. So here in this zone, that means in zone A, we have our traffic parameters QA. This is QA. In those zone, we have our traffic parameter which is VA, and next one is your KA. Next one is your KA, and next one is your KA. Now, in another contracted area, we have our traffic parameter as QB and VB. This is our traffic density, and KB. So basically KB is our traffic density in this zone, VB is our traffic speed in this zone, and QB is our traffic volume or traffic capacity or traffic flow in zone B. In same manner, QA is our traffic flow in zone A, VA is traffic speed in zone A, KE is our traffic density in zone A. So this is Shockwave stream characteristic. So basically this is our Shockwave stream characteristic. Shockwave stream characteristic. Shockwave stream characteristic. So basically, uh, this is your Shockwave model. So the flow of traffic along a stream can be considered to be a fluid flow. Basically, this is a concept of fluid flow because in fluid flow we study about our pipe flow. So we generally study about the contraction of pipe or expansion of pipe. In same manner, here we study about our traffic flow, our traffic speed, and our traffic density in wave model. So the flow of traffic along a stream can be considered to be a fluid flow. Basically, here we consider a stream of traffic flowing with steady state condition. That means all the vehicle in a stream are moving with, I think, constant speed and density and flow. So here let let us consider. So let us consider let us here let us consider due to some obstruction in the stream, I think due to landscape, accident, failure of vehicle, traffic block, reduction in the width of road, etc. with steady state characteristic change and they acquire another state of flow. So these all patterns will be changed and new patterns look like. So basically our new patterns will look like. So this is the new pattern. I plot the new pattern. So this is the new pattern of your traffic flow. So from here, this is your QA, this is your part A. Just wait. Here is your point A, here is your point A, and here is your point B. Here is your point B. So just add point A and point B. Just add point A and point B. This is your traffic flow at A. Next, this is your traffic flow at B. So from this representation, we also see here the traffic flow at A point is more than the traffic flow at B point. So also in pipe flow condition, when generally your pipe are contracted, or if you see in previous diagram, your pipes are contracted in portion B. So when your pipes are contracted in portion B, then your traffic flow, traffic density, and traffic speed will be uh, uh, decreasing, and also it will be less from your point A. So basically this is your QB, this is your VA, this is your VA velocity at A, this is your VA, this is your VB. From here we plot our VB, this is your VB, this is your KB. So use different mark. So this is your KB, this is your KB, this is your KA, this is your KA, this is your KA, this is your KA. So basically this is the plot of your Q and K. So K is plotted on x-axis, Q is plotted on your y-axis. So basically this is the representation of your Q and K. we see here, just we see the speed of vehicle at state A is given by the line OA. So this is your OA line. This is your, when you see, this is your OA line. This is your OA line. So here in diagram, if you see, the speed of vehicle at state A is given by line OA and the state of B is given by line OB. The same speed can also be seen on or shown on same time curve of the traffic stream. All the line having same slope, which implies at they are moving with constant speed. The sudden change in the characteristic of a stream leads to the formation of here shockwave. Hence, shockwave here we see the shockwave is movement of point that differentiate into extreme condition. The slope of line AB gives the speed of shockwave. So basically the slope here, the slope is given by, just observe here, the slope is given by, so basically if you observe here, the slope is given by WAB. So WAB is equal to WAB is equal to QA minus QB divided by KA minus KB divided by KA minus KB. KA minus KB. WAB is equal to QA minus QB by KA minus KB. So the above relationship can also be computed analytically by considering number of vehicles passing through section A and B. So just observe or consider the number of vehicles passing through A and the number of vehicles passing through B is equal. Basically it is not equal because the section A shown in the previous diagram is of your expansion part, because this is your expanded part, this is your expanded part, and this is your contracted part. So generally in contracted part, not much possibility of movement of vehicle or no more number of vehicle will be passing. So basically in this stretch, in this section, more number of vehicle will be passing, and in this section less number of vehicle is passing, but we consider number of vehicle passing through section A and section B is same. So basically when Na is equal to Nb, we know Na is equal to Qa into T. So from here we get Na is equal to Qa into T. So we just get Na is equal to Qa into T. Qa into T. Next, Nb is equal to, we know Nb is equal to Qb into T. Nb is equal to Qb into T. Qb into T. Na is equal to Qa into T. Nb is equal to Qb into T. Put Na is equal to, here we get Na is equal to, just Na is equal to Ka. Here Na is equal to Ka. Here Na is equal to Ka. This is your Va minus WAB, Va minus WAB into T, Va minus WAB into AB into T. Here in same manner we write the value of NB. And now equating both the equation, because we consider Na is equal to NB, that means number of vehicle passing through section A, and also the number of vehicle passing through section B is same. So when we equate all the things, we get this formula, which is WAB, that means for AB is equal to traffic flow for A minus traffic flow for B divided by traffic density for A minus traffic density for B. So basically, shockwave can move against the direction of traffic, as in the case considered previously. This type of shockwave is termed as backward moving wave. Shockwave can also be forward moving if it is moves along with the traffic direction. Example, when width of road increase suddenly or traffic signal goes green from red. So basically, when traffic signal goes from green to red, then we know more number of vehicle will be passing from our road. So basically, at that case, forward moving, or when the traffic direction is in forward condition. So stationary shock wave will occur when two streams having same flow value but different density meets. So these are all about your microscopic model. So in microscopic model, we discuss your green cell model. In green cell model, we just consider our traffic flow. We just consider our speed, traffic speed and traffic density to be constant. Then we derive certain equations of your uh, traffic parameter. Then we move towards your Greenberg model. In Greenberg model, we generally consider your traffic speed and traffic density relationship as exponential. And next is your Underwood's writer methods. So basically, in that method, we also formulate or we differentiate between traffic different traffic parameter. Next method is your pipe pipe method. Next method is your, I think fifth method is your what is your fifth method? Shockwave method. So basically, these are your mm, these are your macroscopic method, and last one is your microscopic model. Basically, this is the another classification of model. So next one is your microscopic model. So just everyone observe here or see here. So next one is your, this is your B part. I think A part is your microscopic model. I covered all your A part. So basically, this is your B part. So this is your B part. B part. B part is your microscopic model. Microscopic model. B part is your microscopic model. Microscopic model. Microscopic model. So basically, in this model of traffic flow, analysis of flow of traffic is done by modeling driver to road interaction within a traffic stream. So basically, in this model, we analyze flow of traffic by driver to driver. Basically, in this method, we analyze this model by driver to driver, driver, driver to driver, driver to driver, to driver, driver to driver, driver to driver interaction, also from driver to road interaction. Next one is your driver to road interaction, driver to road, driver to driver to road interaction, driver to road interaction within a traffic stream with representative analysis by the interaction between a driver and another driver on the road. So this is all about your different models. So basically, for analyzing our traffic stream, we find out two models. One is your macroscopic model, another is your microscopic model. So basically in macroscopic model we deal 5 models. Generally microscopic model is the kind of model in which traffic flow or analysis of flow of traffic is done by modeling driver to driver, driver to road interaction within a traffic stream with representative analysis or the interaction between a driver and another driver on the road. So this is all about your different kinds of model for your traffic parameter. My next point of discussion is, I think, level of service. So this is your level of service. Next point of discussion is your level of service. So this level of service is generally used for our pavement characterization or road characterization. So basically this is your level of service. This is your level of service. So level of service. So level of service is the qualitative measure of user to relate the quality of total vehicle or traffic services. So generally level of service is denoted as LOS. So basically this level of service. So basically my next point of discussion is, I think, level of service. So level of service is the qualitative measure of used to relate the quality of total vehicle or traffic services. So level of service is also denoted as LOS. So level of service is denoted as LOS. So LOS is your short form of level of service. So LOS is your level of service. So LOS is used to analyze roadway and interaction by categorizing traffic flow and assigning the availability list to the traffic based on the performance measure like speed, density, congestion, these things. So here qualitative measure of flow is given by traffic capacity. Basically factor to be considered for the valuation of LOS of roadway includes, so just see, we have 6 level of service. First one is A level of service, next one is your B level of service, now next one is C level of service, next one is D level of service, next one is your E level of service, and next one is your F level of service. So basically these are our level of services. So just I plot parabolic representation of level of services. So this is your level of service A, this is your level of service, this is your level of service of B type, this is your level of service of C type, this is C type, this is of F type. Here we fix the F level of service. So basically we have 6 level of service. This is your F level of service, F. And here your Q max is equal to 1. Here your Q max is equal to 1. Here your Q max is equal to 1. That means your traffic flow is maximum. Here is your Q max. This is 1. This is your Q max. This is your Q max. This is your Q max. and in this direction B denote our velocity in kilometer per hour. So basically we have 6 level of service. One is your A level of service, next one is your B level of service, next one is your C level of service, C level of service, next one is your D level of service, next one is your D level of service, next one is your E level of service, and next one is your F level of service. So basically these are our 6 level of services. So I already said what level of service is your qualitative measure of use to relate the quality of total vehicle or traffic services. Basically LOS is used to analyze roadway and interaction by categorizing traffic flow and assigning the quality leads to the traffic based on performance measures like speed, density, congestion, etc. Here, qualitative measure of flow is given by traffic capacity. Next point of discussion is factors to be considered for the valuation of LOS of roadway include. So basically, what are the factors on which our level of service of road include? First one is your operating speed. If your operating speed is high, so basically factors. So I just erase these things. So next point of discussion is factors. Next point of discussion is what are the different factors. So basically we have different factors on which our level of service will be depend. So first one is your OS operating speed. So if your operating speed is high, then level of service required on a road is more or be required higher level of service. Next one is your travel time. For less travel time, be required our high level of service. So basically we required F level of service. Next one is your traffic interaction. If we do not want more traffic interaction with other driver or certain other things, then we required also better level of service. Next one is your freedom of movement. If we allow freedom of movement to our drivers or easily movement of our vehicles, so we require also high level of service. Next one is your driving comfort. So I think these all points are understood from your sides, or these all points are very easy, which you all understood from your side easily. Next one is your safety. If we want higher safety on road, then also we require greater level of service. And last one is my economy. So for economic point of view, also we required our level of service of good type. So as per highway capacity manual, following factors are considered to be evaluate LOS. What are the following factors? So basically these are the factors which I discussed earlier. That means operating speeds, your travel time, traffic interruption, freedom of movement, driving comfort, safety, economy. These are the basic points which will be our factors which governs our LOS, that means level of service. So the IRC suggests 6 level of service ranging from A to F, having following property. LOSA, that means level of service A, free flow operation. In LOSA, free flow operation, no restriction in maneuvering, low traffic, and also we provide higher density in the case of our LOSA, that means level of service A. So I think at here we stop our class, or we discuss next thing in our next class, most probably on Tuesday is your next class. So on Tuesday we meet with you. So I start from your 6 level of service. So I discuss in next class what are the different level of service. In today's class I discuss what are the different kinds of level of service: A, B, C, D, E, and F. Now in next class I elaborate all the things in detail. What is LOSA, what is LOSB, what is LOSC, that means level of service C, level of service D, level of service E, level of service F. All things discussed in detail in your next class. So thank you everyone.